This is the fourth KEP review meeting dated March 25th, 2020, for review of the Object Bucket API into Kubernetes. So I'd like to start off by going over our change list here, if that's merged in. Has the Google Doc come up on the screen share here?
Yep.
Great. Okay.
Yes.
So I've kind of broken this up into two sections: change list, things we actually did; discussion points, things we'd like to bring up. So starting at the top, as usual, same rules apply. Please feel free to interrupt me at any given time with questions so we can address them right then. These points are designed, or I'm hoping to generate questions, comments, discussions around each of these points to varying degrees. And to that end, please chime in whenever you have something to say. So the first point, we've deduplicated a lot of the fields in the APIs. Initially, we had some fields copied into the bucket content, either from the bucket class or from the bucket API object. We've since limited those so that, for the most part, fields in the bucket are now represented in the bucket class, so that we adhere to the principle of users are not passing parameters and data to the driver directly. They're selecting it from whichever bucket class they reference. And then the sidecar, to avoid deduplication, or duplication rather, of fields and having to draw data from different sources, the sidecar is getting the bucket class and pulling all relevant fields out of that. And what that looks like, for the most part, is the bucket content object now has been reduced to referencing the bucket class, the binding bucket, the secret reference, that's for the generated secret, and the actual name of the object store bucket. And then bucket attributes remains for stateful driver data required for deprovisioning phase, as is common, and of course conditions.
Sorry, can you walk through those fields again? I'm slow.
Yeah, no worries.
So we've got bucket content, which is equivalent of the PV object.
Correct. Yeah, apologies if I'm going too fast. I'm sufficiently caffeinated.
No worries.
So, so let me give some brief description. So bucket class name is bucket class synonymous with storage class, referenced by the bucket content object. So this is the cluster scoped object synonymous with the persistent volume. A bucket ref as a back reference for the bucket API object. So that's equivalent to the PVC. This I do want to call out.
Got it.
We don't have a case where we support pre-binding. So if this were defined manually, it wouldn't have an impact on provisioning. It's mostly for a deprovisioning, so that the controller knows, which bucket content object was generated by which bucket.
So just a quick aside here. This is not this doesn't look like a full reference. So the UUID stuff and all of that, or UID and all that, is missing. Is that intentional? And what about, do you have concerns about race conditions, et cetera?
It is intentional.
Do you know what I mean?
With race conditions,
thinking of, Andrew?
Yeah.
What race condition are you thinking about?
I create a bucket. Provisioning starts on it. I delete the bucket. Then I create another one with the same name. Those kinds of things. Like when I'm playing with one side of it while the other side is active.
Right.
Right. No, actually, that's a really good point, and probably something we need to add in here.
So like the PV would include like the UUID and the resource version of the thing.
Yeah.
Mm-hmm.
Yeah, exactly.
Yeah.
That's what I was referring to.
Great. Yeah, we'll take a closer look at that and make sure that's added in. Secret ref here is the secret within the namespace of the driver, so it's the generated secret and the one to be copied to the app space. Now, on that note of race conditions, that's also interesting because secret references as defined types in Kubernetes are just a name and a namespace. So that may be something we want to expand in the same way that we want to expand the bucket refs.
So the concern for a race condition isn't there because secrets can be created after the bucket content, or they can be deleted and recreated, and that's okay. Similarly with
I agree.
Like, class names can be deleted and recreated, and you just have to deal with that.
Interesting.
Right.
Okay.
And
yeah, no, good point. So the object bucket name is the name of the actual bucket or container in the object store.
But
can you expand on that? What does that mean?
So
physical bucket name in the object store itself. It's the
So this would it be unique per backend? So if we're talking to S3 versus GCS, for example, would this be the bucket name in that backend?
Yes.
Yeah. So
how do you?
Go ahead.
Sorry, go ahead.
Well, I think
there's a delay. It's weird.
I think maybe it might be more instructive to go through the APIs. This in a previous version, we had admins creating a bucket content resource as a.
I think the only weird thing to me here is I'm
now
expecting. Sorry, go ahead.
Well, and now we're not creating this. There is no manual creation of a bucket content in this latest revision. It's generated.
Right. I think the concern I have is around kind of lack of what type of bucket is this, because the object bucket name alone is kind of irrelevant, right? If we're talking about an S3 bucket versus a GCS bucket, how do I know that from looking at this object?
You'd have to dereference the class, I'm assuming.
Correct.
But
yes, correct.
We should not do that. Like once a bucket content object is created, as much as possible, we should have everything that we need to access that object or access that bucket in this object.
Okay,
yeah.
so
he's suggesting the opposite. Oh, go ahead, Jeff.
Well, we did that originally. The revision N-1 we had fields in the bucket class replicated in the bucket content. The idea was that was a snapshot of how that bucket was created, and you could alter. Right. You could delete the bucket class, and we still reflected the bucket, the physical bucket.
If you ask him, that was a mistake we made with PV/PBC, was not kind of replicating the entire class in the PV object. But at the very minimum, we put in enough information that you can connect to a volume. So we should do at least that.
So this revision represents deduping of that, trying to have a single source of truth for this information. But your point is the same point we had just a week ago, and so we'll put those fields back in. This is good feedback. It basically.
Okay, sorry about the back and forth.
It's over. No, it's fine. That's how this stuff works out. It's fine. Because what you're saying is it's more important to have a snapshot, an accurate representation of how that bucket was created, than it is to worry about replicating field values across resources, and that's fine.
It also means the sidecar can only operate on this object. It doesn't need access to the class.
And we figured and agreed, Andrew, we weren't looking at that API call as a big deal in the design, but it's more what you're saying about accurately representing the bucket that was created. And the only way you can do that is to capture all that information at one point and stick it in the bucket content.
So I have a related but slightly different point. When we were looking into bucket identification, I think we came to the conclusion that bucket name was an insufficient identifier for some backends, and that we actually decided to model this as key value instead of just bucket name. Because, for example, you might not have a globally unique domain in your back end. You might have to provide another, like a region and a bucket name. And
we had this discussion with CSI where a similar argument was made for volume ID. And what we landed on was, well, it's as far as the consumer is concerned, it's an identifier. And it's up to the plugin to decide what they stick in that identifier. And they should put in all the information they need.
This is defined as an object bucket name. And
right. So what I would suggest is rename this to an object bucket identifier, and that way it corresponds to what the CSI, object bucket identifier would return. And like as far as the CO is concerned, we don't care about what the name specifically is. We care about what the identifier is that we can use to interact with this thing, right?
Right. And so if the identifier ends up being a composite piece that has 3 different fields, you don't care whether that's serialized JSON or dash.
Don't care.
Fields.
Exactly.
Well, let me interject real quick too. So the object bucket name or identifier field here is actually not it's more for the driver tracking than it is for the user tracking. All pertinent data for user connection is still stored in the secret here as a, we were thinking we were going to prescribe 2 strictly named keys, one for endpoint, one for credentials within the secret. And so from that point of view, the bucket name is actually not a consumed field by the user.
Okay, so you have multiple key values in the secret ref, which would mean the driver itself for deprovisioning has to poke into the secret?
I would say that we would have 2 parameters defined, one as a string of like an endpoint and then a credential structure that we would pass to the driver.
You understand my point. My point is I understand the credentialing piece, but I'm saying just identification alone for some backends is not a single key or endpoint, right? Because it might have a regional identification, it might have a project identification. There might be a couple of different things that are necessary to be able to scope it.
Oh yeah, and I've seen that. That's usually represented as like a kind of a directory path format string.
So if you think about it, there's kind of three pieces of information that we want to capture. One is a identifier that lets Kubernetes interact with a COSI driver and say, this is the bucket that I'm talking about. So it has to be some unique identifier that alone, that string uniquely identifies the bucket. The second bit of information is what is all the information that Kubernetes will need, or a workload on Kubernetes is going to need in order to connect to this bucket. And then the third piece of information is what is the kind of secret or credential information that's required. So it makes me uncomfortable when we take a lot of that information and we stuff it all inside the secret, and we make, like Andrew said, the bucket name isn't really a unique identifier. So we should have those 3 as like distinct sets of kind of fields or sets of fields.
Yeah, I think the endpoint versus credentialing information discussion is what came up way back at the face-to-face. They had originally split this into a config map for the endpoint and a secret for the credentials. And the feedback was, well, there's no harm in putting the endpoint into the secret, and that reduces the number of moving parts and just adds to an overall efficiency, even though it does give the implication that it is all secret data when in fact some of it is endpoint.
Exactly. I think I would argue that we should be able to have everything except the secret information in this object to interact with this object. So if I want to be able to connect to it, the endpoint information should be in this object. It doesn't make sense in the bucket content. Like the bucket content is a representation of the bucket. How I connect to that bucket, that information should be represented here. It does not make sense for us to stick that off into a separate config map or secret.
Well, is that in line with how we would do it in a volume, though? I mean, still
Yes.
volume.
So like if you look at a PV object, you'll
Yep.
notice that every PV object has all the information that it needs to interact except the secret in the PV object.
And that's what I was getting at. I thought the secret was separate, but we're just saying we'd have a reference to the secret in here like we do in the PV object, but otherwise.
Right, and that's perfectly fine, but let's use that only for things that are actually sensitive, not for actual connection information.
I agree with that. I think we should be able to trace it through the system. Even if we're just doing it for ease of use to debug, it's important to have that in place.
Right. The one hitch with that, though, is that we still need to communicate the endpoint information back into the workload. And the secret is right now it's our vector for that because we can't inject it, obviously, from the CR. So
right.
I'm not arguing against storing that information, the non-sensitive stuff in the bucket content. I agree with that.
So it sounds like there's two different problems here. One problem is how to represent it in bucket content such that the endpoint is directly accessible to controllers or other things that are operating on this content. A separate question is how do we expose this information to workloads? And in the workload case, it makes sense to combine it all into a secret because a single secret can be mounted and you can pull all that data out. But you wouldn't want to opacify it into a secret in the content, I think is what I'm hearing.
Yeah, I think that sounds like exactly the problem. So for the second part of how to surface it into the workload, instead of trying to hack this and piggyback it off of secrets or config maps because it's convenient, we need to consider making COSI a first-class thing like CSI is, and kind of Kubernetes knows natively how to fetch these objects and surface them in the right way.
So you're saying we have to do core Kubernetes plumbing in order to get these mounted, like in addition to config map mounting and secret mounting, we have COSI.
Right, because what we did with CSI was it was an extension mechanism. It's moving most of the volume plugin code completely out of tree, but it still needs that kind of connective tissue to be able to mount and do all the things that kubelet, et cetera, need to do. And so similarly with this, I mean, we can consider like a pre-alpha where we kind of hack around this using mounts or using secrets or config maps or something, but ultimately we're going to need some connective tissue that says, hey, I recognize what this object is and I know how to handle this specially and surface it up into a workload. And that would be what an alpha would look like for me.
Is there any move towards a generic version of that? I mean,
it's hard to do because it depends on how we're trying to surface it. So I think what we're trying to surface it as is environment variables, right?
Right.
Well, no, the problem with environment variables is what if you have two buckets that you need to access?
Right.
So what is the current proposal for how to surface it to the workload?
Mount it as secrets. So you can, as long as the workload knows it's expecting these things, you can do that. You can also do it as env from, but we found that pretty much limits you to a single bucket.
Okay, so we're talking about essentially mounted as files. What we could do if we wanted to simulate this without doing a lot of surgery on the core is have temporarily a intermediate CSI driver that does this. The CSI driver would know how to basically interact with bucket content objects, and it can create a file that gets surfaced up into the container. That would be kind of a hacky prototype way of getting what we want. But you could also use secrets and config maps. But if you want to keep the interface clean and get the bucket content closer to where we want it to be, that's another option.
Yeah, we have definitely kicked around the idea of approaching it from that angle. And I mean, frankly, the only reason we didn't is we thought that the time scale that would require from our team and the amount of effort and stuff it would take may be too long for us to actually be able to see the project through or at least get it accepted. But if that's a viable option for us, I think that we're all for that. Man, the use of secrets is a hacky workaround regardless.
Yeah.
It's not necessarily the intended use. It works well in that the application pod is stalled. It doesn't launch until the secret's mounted. So that's a great synchronization mechanism for us.
And if you did a CSI driver, you'd get exactly that behavior too.
Does that, Saad, right now it doesn't seem like there's any dependency on the kubelet, but what you're suggesting is maybe there would be, in the sense that we would sort of mount, in quotes, a bucket. And there could be multiple buckets, which is nice because secret doesn't work very well with multiple buckets. So that to me is a functional advantage of what you're saying, because it's a natural way for an application to access more than one bucket.
And something about the mounts when we talked about this a long time ago that didn't seem to make sense. I mean, I'm all for creating a consistent way of doing it, and I think this should ultimately probably be more part of the CSI spec personally, because that's the direction we're going. But I feel like when we looked at this, there was something with having the mounts that was funky.
Saad, were you thinking about a new ephemeral volume type called like object volume, object bucket volume? That would initially be CSI, but maybe core?
Not really.
Yes. For a prototype, yes.
But to be clear, this is an object bucket access volume. It's not like
right. All the volume gives you is the details so that you can go mount the bucket.
Exactly.
It doesn't give you any data.
Right. There would be basically just a way to integrate.
So as long as you do that in CSI, there's no core work. And then, if you want to promote it to be a core thing, then you've got core work to do.
Exactly. It'll give us a nice kind of stepwise way of having a way to prototype, get an alpha out, and then we can consider, hey, is this workable or is this painful, and do we need to pull it into core?
Yeah.
But going back to Aaron's point, was there some concern about surfacing as mounted files versus, I guess, the alternative is environment variables?
Well, the one advantage of environment variables is that an application doesn't have to be aware of this credential passing, right? If it uses a standard client-side API, most of those respond to environment variables. So the simple case, it's much easier to adapt existing workloads to this if you have a single bucket, if you can just leverage environment variables.
Right.
The other normally used to doing it. I think that was our main reason. And then we also didn't need a finalizer or any of the other things. I mean, I guess I was using mount in the context of how volumes today in Kubernetes was a bit overkill for what we needed for object, but maybe if it's a variation of a quote unquote mount, it would be sufficient. But I do agree with Andrew's point about application consumption.
What if this became part of the downward API, so you could just reference these things in your pod definitions? Would that help? Would that alleviate the need to lean on environment variables? If you could just refer to these things through the downward API?
I think that ends up being kind of the natural direction this would end up in. Maybe start off as a CSI driver with mounted file as kind of the only way to do it. And then before we go to beta or GA, we say, hey, we're going to promote this into a what do we call it? One of the core downward API type volumes. So then the user has the option of surfacing either as a file or as an environment variable.
I don't really get what's the construct that when you say downward? I'm sorry, I'm not.
There's a set of ephemeral volumes built into in-tree Kubernetes that allow Kubernetes to fetch information and surface it as files. So they basically create an empty door.
That's the question I have. It's the other question. How do you do this with environment variables in a way that isn't basically an env?
With those types of volumes, the secrets, config maps, and downward API all allow not just to be surfaced as volumes, but also as environment variables.
Yeah, it's that last thing you talked about, downward API. I'm not. Can you
downward API is just think of it as secrets and config maps, but instead of fetching secret or config map objects, they fetch other Kubernetes API information and surface it as file or environment variables.
So Andrew, It's basically like strings you can put into your pod spec that refer to other Kubernetes objects in a way that when that pod starts up, it can get data from those objects.
And it can ensure that those other objects are provisioned before the pod is started? That's the thing that I'm trying to understand.
Yeah, I mean,
I forget what
I would assume that would be
exist.
Kubelets' job to not start the pod until all the downward API objects that it needs are there.
Mm.
Like you can refer to a config map that doesn't exist in your pod, and then Kubelet should fail to start that pod until the config map turns up.
Right.
It would also be nice to be able to have an option not to mount this and not to expose it as environment variables. For an application that's more security sensitive and wants to fetch the secrets over Kube API, that way they're only in the application memory and they're not exposed to the rest of the container.
That is an interesting thought. You mean so basically don't have any automated way of surfacing it, just create these objects?
Or at least be able to disable mounting it. Like with a secret, I can mount it, I can expose it as an environment variable, but if I do nothing, it doesn't expose it. I'd like to have that same behavior.
So let's say, hypothetically playing out the design we're talking about, we're going to introduce some sort of volume type or something like that that says I want an object bucket and this is the object bucket I want, and I want it to be surfaced as a mounted file, or I want it to be surfaced as an environment variable. If we have such an API, you could imagine a pod that doesn't use any of that, and it just goes out and directly fetches the object bucket and object bucket claim API objects directly, and then it can do whatever it wants with them.
Yeah, so that's exactly, by the way, how we do this. So you can imagine for a backup application where you're into each individual backup, you may specify a different claim or bucket as a target. That's not a situation where your workload can mount volumes because that set of volumes is dynamic. But if it's Kubernetes aware application, it can just literally go retrieve the object bucket and theoretically object bucket content if it's got the ACL for it.
I would caution against doing that for security reasons, though, because you're basically giving the workload access to basically fetch all of these objects.
Yeah, in this particular case, that's warranted because a backup needs to be able to fetch all.
Okay.
Yeah, and the main advantage that I see for having that kind of access is just where the credentials are accessible in plain text, right? If the application is aware, then the only place where those credentials are in plain text are in the application's memory, and it could encrypt it there if they wanted to. And then, if you mount it as an environment variable or as a file, then they're plain text inside the container throughout.
Got it.
This has been kind of an eye-opening discussion for me. This is Jeff, and maybe John and Aaron as well. Because your suggestion, Andrew and Saad, sort of, coherently here or together, you're kind of talking about making this more deeper into sort of Kubernetes DNA, where it's really is a first-class citizen. And ways that we could get to that point, either through a hack to the cozy controller that understands objects and other areas of discussion around how we can inject information into the workload. And all of those to me are very appealing. But do you see a short-term value in what we're proposing here? In other words, what would be MVP in your guys' eyes? Because like Aaron mentioned, your ideas could be adding another year or year and a half before this stuff actually ends up being available for users. And we'd we'd like to shorten that if we can.
Yeah, I think MVP for me is let's get the API objects looking the way that we want, and we can hack around how we surface it up into the containers. Because if we can get agreement on what the API looks like, then everything else kind of will fall into place. And that includes what the COSI API looks like and the Kubernetes API.
Yep, I think that's the right approach. And that's locked down. We don't change that.
I mean, between alpha and beta, we leave the option to, because inevitably once we try it, there will be something that doesn't work quite right. But we want to get it to a place where we're like, yeah, this could, feasibly, as far as we are aware, work. And the reality is, like, we started CSI with CSI 0.1, 0.2, 0.3, 0.4. We had 4 releases before we went 1.0. And that was because there's no way that you're going to get it right the first time. And it's good to leave yourself open the option to be able to revise and break things. With CSI for volume resizing, we introduced it after 1.0, and it's been a struggle because it was added directly to the 1.0 spec or 1.1, I forget, as a GA feature without kind of going through alpha, beta, GA, and now we're discovering a bunch of edge cases where it's like, ah, shit, if we went through alpha, beta, GA, we would have kind of had, time to revise and iterate and break things.
Right.
So
Okay.
Sorry, are we going to take this discussion back to the actual representation of the object and talking about the details of object bucket identifiers, or are we going to postpone that?
No, I think that's what, I mean, that's the lowest common denominator right now for us to have something to code to.
I mean,
so
that's what you're saying we need to settle on, and then the rest of it.
Yeah, I'd say settle on the API for both the underlying COSI API and the Kubernetes API, and then focus on how you're going to surface it.
Okay. Because I had a concern. You had suggested we change object bucket name to be object bucket identifier, and then let the driver decide what that needs to be for that particular object store. What do you have in mind for?
So what I'm thinking is we always need some kind of mechanism by which Kubernetes can talk to a storage backend and definitively communicate what bucket it's talking about. And we need some identifier. There may be other information that's required for connection, et cetera, but just for saying, hey, I want to do this operation on this bucket, there should be some mechanism in COSI that returns a unique identifier, and Kubernetes should be able to use that unique identifier in the future to operate on that bucket.
Yeah. So the concern I wanted to raise about this is the same one that's bitten at least me on the CSI side, which is if you just make it an identifier and it's a string and you limit its length, that makes certain objects impossible to refer to if their names exceed your maximum string length.
Yeah, I think the CSI side, the maximum string length on the identifiers was unnaturally low. We should fix that.
Okay. Yeah, it's been a source of pain to have a 128 character, or it's actually 128 byte.
If you want to propose a update to the CSI spec to loosen that, I would totally be on board for that.
Okay.
Yeah, that was a comment I was going to make earlier, is if we assume that this has to support composite information into a single string, we've got to be really careful that we can do multiple reasonable sized things.
Right.
What would we consider a reasonable size thing? I'd like to have that recorded so we could talk to it later on.
Thanks, John.
So the first question is, what's the maximum bucket name length in most of these backends? And it's particularly since it's likely that we're going to want prefix plus UUID. So you start with that, and then you add things like region identification. I know that Microsoft has some weird ways of identifying things, so they pass additional information in as part of the identity. So basically, I mean, the way that I would probably do this is just literally serialize JSON or something, but you could also do it with some sort of, positional parameters separated by characters that are not allowed in the underlying thing. But
yeah, I'm sure we can figure out what the right size is. In Kubernetes, or in CSI, it was arbitrarily set to 128 bytes, which is definitely not sufficient. So we know that that's not sufficient. We can figure out what the actual right limit is. We don't need to decide that right now.
Okay.
But
I mean, the goal would be
256 is probably not unreasonable.
Yeah, I mean, like the goal is let's figure out like some examples of all the information that we're going to want to stick in this thing, figure out an upper max, and then maybe 2x that just to be safe, something like that. But we don't need to do that exercise yet, like right now.
Okay.
Gotcha. Okay. Sounds good. And then just so everyone knows, Jeff and I will be going back through this meeting and kind of recording it as minutes, so we'll be able to parse a lot of this information out. It won't be just lost to the ether. Other comments or questions or critiques for bucket content? Or should we go ahead? We'll update it, and then maybe we can gen up some more.
Yeah, I guess probably the biggest thing that we ran into here was the pushback on the dedupe work, right?
Yeah.
So
Yep.
Exactly.
go up in a couple of places.
Yeah,
Yep.
yeah, that's going to be a big guiding point for us in reworking this before next week. So yeah, we'll see some major changes here, I think.
Yeah, let's make those changes, and then we can revisit the status part of it next time.
Okay.
Yeah, and we have 20 minutes left. How would you guys like to spend the 20 minutes? Because John has written down 2 discussion points in the doc that's in chat. Would you guys like to talk about those in our remaining time, or other API changes that we made?
Whatever you think is the best use of time, I'll let you guys decide since you're running this.
Maybe
I'd
we
like
can-
to.
Oh, go ahead, John.
Jeff, if you don't mind. Yeah, let me talk to the second discussion point here, because I brought it up last week, and we had some agreement that was a good idea, and then in running through it as thought experiments and trying to logic out the paths and things, and also speaking to a few folks and how it was solved in CSI, we've discovered it's a lot more complicated than we initially thought. And that was, how do we prevent duplicate driver names running in the same cluster? So say 2 drivers are deployed, they're both named foo, they're now both looking for buckets named foo. This seems problematic. We spoke to Jan about it, and he said CSI effectively punted on that, and we thought, well, we'll see if we can solve it. And there's a few cases where it works if everything is perfect, basically.
So, I mean, CSI didn't punt on it. What CSI did was, if you look at, let me pull up the CSI spec. There is the plugin. But effectively, there's something along the lines of a plugin name. And what CSI did was say that that name has to be fully qualified such that, let me pull up the exact wording. It's basically like a domain name. And so that kind of prevents collisions. If you have, a CSI driver from Amazon versus CSI driver from Google, they both can't be called CSI drivers. The fully qualified name will be like Amazon.com/CSI driver, Google.com/CSI driver. And so that effectively prevented us from running into this issue.
It doesn't prevent.
Well, where are the checks from that?
Or reduces the likelihood.
I see. So yeah, it's not a. We were talking like a programmatic enforcement.
Is that enforced, Sod, the name?
Yeah, so the exact wording on the spec is plugin info response. The name must follow domain notation format. It should include the plugin's host company name and plugin's name to minimize possibility of collision. It must be blah, 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 63 characters or less. This is all to make sure it aligns with the Kubernetes API, and this field is required.
So there's not a. Sorry, go ahead.
Yeah, I'm sorry, I'm leaping ahead. So yeah, so that's the sort of non-programmatic, right? So I guess the question that I have is, I was assuming that the COSI registration process would look a lot like the leader election stuff. where you sort of first one to create the resource kind of thing. But you ran into, when in the thought experiment of diving down that, you ran into a problem of something not being cleaned up if you had a driver crash, and then I assume never being able to then bring the driver back up. Was that sort of the... That's
hit the nail on the head there. So everything works great when two food drivers are deployed, and they each, through automation, not through manual creation, create a cozy registration driver. One of them will fail, but it's a synchronous operation because it's calling, kubectl, or not kubectl, but the Cube SDK create in code. So it's failing because it can't create it. That's great. The problem comes in when either it's a cleanup problem regardless, but either a driver's deleted, you can't do an owner reference from a cluster, of a namespace object. You can't make the cluster scoped object dependent on that. So there's no automated cleanup. What happens if a driver either keels over and reboots, then it tries to recreate it, can't recreate it? That could be solved by saying, oh, well, we'll just do a get ahead of time. But that actually just makes the cozy registration a moot object. Yeah, because it already exists, and you could have many.
But doesn't leader election use some sort of polling mechanism where it has to refresh the credentials multiple times or something like that? And so if somebody hasn't refreshed it recently, you assume it's stale?
I'll have to look into that.
Well, Andrew, we didn't look at leader election for this. That's an interesting idea. We didn't, at least I hadn't thought about that. But
because leader election solves a lot of the interesting problems around these kinds of race conditions, I think. But having said that, this was mostly just interesting because you sort of pitched it as a problem for which there isn't a solution, and I thought there might be a solution. But if we think that the domain name thing sufficiently disambiguates these so that the likelihood of collision would have to be kind of intentionally created, and then it's your own damn fault.
Exactly. Yeah.
If it's intentionally created, does that possibly provide a way for someone to get access to
malicious?
That's the other part of this, right?
I mean, we've always had that discussion with volumes as well.
So what we said with CSI drivers is that they're basically privileged administrator installed things. And so if you have a driver that is malicious, all bets are off. They are highly privileged. They have access to everything. You know, as an administrator, before you deploy that piece of software, you need to know what you're deploying.
But
also, let me say too that we may have one extra lock that I'm not sure if volumes have or not, and that's that the driver has to be credentialed with credentials for that object store to even operate. So if it's not enough just, unless those were hard coded into the driver, in which case that's probably not a great idea. But even deploying a driver, I could deploy one as a user in my namespace, but if I don't have credentials for administrative roles in that object store, then it's not doing anything anyway. And ACLs should prevent me from accessing bucket content objects and the backing secrets, which would be in a protected namespace.
Yeah, they could probably get away with some denial of service and, I don't know, probably accessing something in the API. But yeah, that's a good point.
At which point the cluster owner finds them, tracks them down, and smacks them.
Yeah, exactly. So we hit a point in thinking through this where we were wondering how much work is going to be required to bias what has a lot of safeties on it already.
Yeah, I'd say you don't need to completely solve this. I think just saying, just preventing accidental collisions is sufficient. No need to go beyond that and try to prevent malicious collisions.
Preventing accidental collisions is that just
documentation?
Yeah. Not through code. Okay.
Yeah, and then the convention of doing a full domain name, that does a pretty good job. Within your own org, you might step on each other, but at least cross company, you shouldn't.
And
Right,
I
right.
pasted a link in the chat window for the existing driver names. Folks are mostly following it. There are some folks that are not, but
Thanks, Don. Yeah, and the consequence of not following is that you can have two sidecars watching the same object, right? The same bucket
Right.
content in our case, in CSI, the same PVC, I guess. But and then you get unpredictable results. They're both working simultaneously on the same watch when they shouldn't be.
right.
One last thing, Andrew, you had mentioned leader election as a possible solution for this. I'm kind of tangentially aware of how leader election works, and from what I understand, it's, I don't know if limited is the right word, but it operates mostly within like deployment controllers, or not controllers necessarily, but deployment stateful sets, things of that nature, where multiple pods of the same container are deployed.
Well, controllers, right? This is a common thing. How do you get multiple controllers, even when you only want one of them active? How do you have multiple of them up so that if the primary one fails, you can have another one pick it up right away and not have to redeploy, right? And so I'm not suggesting it's exactly the right mechanism, but I'm suggesting that what they've done to try to beat races in the implementation of that seems like a reasonable approach. And I'm not 100% clear on how it works. I've just done a sort of skim overview, but my understanding is it basically like creates a resource object in etcd and then refreshes it periodically to say, I'm still here. And everybody sort of periodically tries to become the leader. And you have a sort of mutex, not really exactly a mutex, but an equivalent of that. And so somebody wins, and that a death eventually is detected. And the eventually here is sort of based on polling interval. So, in seconds.
Mm-hmm. Okay. Yeah, and that, at its core, that's kind of what we were thinking would be required ultimately, is some sort of stateful store for who actually has registered and who hasn't, that kind of thing, which is what we lose with the registration object. Or rather, sorry, to be more clear, a stateful state in like a runtime, so we're constantly maintaining that.
My takeaway from this conversation on this discussion point is it's not needed for MVP. The DNS naming convention and documentation are sufficient for now, and we can kind of forget about it, this cozy registration object.
Yeah, it hasn't been a big concern on the CSI side.
Yeah, so let's do that, John, because there's other areas that need more attention.
Agreed. And we are, well, this was a 50-minute meeting, but if y'all are comfortable going to the top of the hour for the next 9 minutes.
I can't quite go all the way to the top of the hour, but I could go another 5 minutes.
Okay, great. We had added, as part of the API, 2 cases we wanted to talk about, or at least put front of mind for next week for the release policies. So currently we have delete and retain, and they perform destructive deletions, or it's currently defined as deleting all the Kubernetes, retain deletes all the Kubernetes layer representations, but does not delete the backing storage. There was additional thoughts on reuse and erase, reuse effectively being recycle, I think, or erase where the bucket is preserved, but the data inside the bucket is terminated. Just wanted to know how that passes a smell test with you guys. Next couple of minutes.
I'm not a super big fan of something so clearly in the application domain as erase.
Yeah, I'm going to +1, Andrew. When we started PVPVCs, there was 3 retention modes. There was basically retain, delete, and there was a recycle. We ended up deprecating recycle for exactly the reasons that Andrew is smelling, which is it becomes extremely challenging to actually do correctly and securely, and it's a pain.
I fully agree with that. It was a nightmare. And I know that this request came from, current object providers because they do something similar, but it's just too hard to manage.
Yeah.
Okay.
Yeah. We shouldn't
Yeah.
even open that can of worms, please.
Where you just saw it, and you
Okay.
just saying the only release policies we need are retain and delete.
Correct.
That's what I would say.
Because we talked about in the last meeting reusing an object bucket content, which we said no to. But we know that object names, like for S3, are world global. So sometimes, a bucket name, sorry. So sometimes you get your desired bucket name and you don't want to release it, but you want to erase the contents. And so I know
that becomes an application level concern at that point. Like if you know you're getting a bucket and you want it to be empty, check the contents and take care of that. That's becomes an application level concern.
Yeah. Okay, they're already implementing the SDK at that point, or using the SDK at that point for that client. Yeah, so that makes sense. Jeff or Aaron, are there anything else you want to bring up before we close?
No, definitely get rid of the erase. I think we should circle back and update this list, send it out to the wider mailing list, some of the suggested changes we've done about the API and how that's going to be integrated, and find our MVP and make sure we get consensus on that.
Okay, sounds good. And
Saad, do we have this on? I know we're a ways away from this, but should we put a pin on what release we feel like we're going to try to aim some of this for?
So we're going to do Q2 planning, not at tomorrow's meeting. Tomorrow we're going to do kind of a wrap up of everything that we did in Q1, but at the subsequent meeting, which is on the 9th. And so we could discuss it at the Kubernetes sig-storage meeting on the 9th and say, hey, what's our goal for Q2? We should definitely track it as a work item, but what's the deliverable? Is it a design? Is it an alpha? And I think hopefully in 2 weeks we'll have a better idea of what's feasible.
Yeah, okay, that sounds reasonable. Thanks.
All right, on that, I'll say thank you guys as usual.
Yeah.
It's very appreciated.
Thank you for driving this. Super exciting.
Yeah, thanks. All right, yeah, I'll have the recording posted to the discussion board and send out a invite for around the same time next week.
Cool. Sounds good. Take care.
All
right.
Thanks, everyone.